Astronaut. He was a mission specialist. He graduated from MIT in June of 1984 with a degree in physics. He attended graduate school at the University of Texas at Austin, working in the Center for Relativity and then the Fusion Research Center. He received his master's degree in 1988 and joined the U.S. Navy, reporting to Aviation Officer Candidate School in Pensacola, Florida. He was commissioned in January 1989 and earned his wings as a naval flight officer in March of 1990. Woodward made 2 deployments in support of Operation Desert Storm after the ceasefire. He also to Southern Watch and Somalia. In 1995, he was selected to attend the U.S. Naval Test Pilot School and graduated with distinction in July of 1996. Upon graduation, he cross-trained in the FA-18 Hornet and tested stores and systems for the FA-18B and the FA-18D and FA-18F aircraft. Woodward was assigned to the Strike Aircraft Test Squadron when he was selected for the Astronaut program. Woodward has logged over 1,700 hours in more than 25 different aircraft and has 265 arrested landings. That means carrier landings. He was selected by NASA for the Astronaut Corps in June of 1998, and he reported for training in August of 1998. Woodward is currently on detached duty to NASA headquarters as Director of the Integration Office at the Exploration Systems Mission Directorate. Would you please give a warm welcome to Neil Woodward.
Okay, good morning, ladies and gentlemen. We're kind of fighting a couple of small technical issues this morning. You might see a little bit of activity up here as they're moving laptops and everything, but I'll try to continue through this with a minimum of disruption. Just a little bit of discussion about how I got here today. As I said, I was selected for the Astronaut Corps back in 1998, and the reasons that I'm here representing headquarters and not the coming up from the astronaut office is I took what was going to be a temporary duty back in 2004 up to headquarters when they announced the exploration vision. And I thought that sounded pretty cool. And it was only supposed to be for a year, and then it kind of became 2 years, and now it's been 3 years, and just the excitement of working on this particular program and stuff, I'm still up there right now. So still got the option of going down to JSC at some point, and I'll do that. But right now it's a good time to be working on the vision. So if I can have the next slide, please. Okay, now what am I going to talk to you about today is pretty much the top level headquarters view of our exploration vision to give you an idea of what we're trying to do and why we're trying to do it, and how this kind of flows down into our what we call our global exploration strategy and then our lunar architecture. If you can see here on the screen right now, the way we think about this is if you're going to take an exercise like this, an effort of the scale of going back to the moon and the amount of resources that's going to be required to do that and the amount of time, you really need to have a lot of questions answered before you start bending metal. And that is things like, why are you trying to do this in the first place? You know, what national needs are you addressing? If you get there, what is it exactly that you're going to try to accomplish? You need to have those questions answered, because then they'll feed back into the sort of decisions you make on your hardware and the capabilities that it is that you're building. If you don't have those answers straight to start with, you might not find yourself with an architecture or a series of elements that don't really address the important things when you get there. So we realized when, after we got the Constellation program up and running at the early part of last year, we at headquarters started to turn our attention towards those questions. And as you can see here, we have what we call we worked on what we call the global exploration strategy, the architecture assessments, what we call the lunar architecture teams, and how they relate to the technical requirements down at the bottom. Primarily, let's think about the global exploration strategy first. That is the why are we going back to the moon and the what are we going to do when we get there. When we calculate all that out and you poll your stakeholders, and I'll discuss that in a moment, what you're going to get is a series of national priorities that can then inform your lunar architecture. Excuse me a moment. Thank you very much. Okay, now I don't have to read the slide backwards and the mirrors in the back. That'll be a little easier. So what you're going to get out of the global exploration strategy part of this is basically we got themes and objectives. The themes kind of answer the why and the objectives the what. Now that you've been able to define your national, your international, your commercial priorities, you kind of know what's important of the whys and the whats. You can drop that down a level into architecture, and that is when we're putting together all the various moving parts of the system that's going to take us back up to the moon, how are these priorities informing them? How are they going to inform the requirements on those? From this particular architecture assessments, we're going to get things like the reference architecture itself, and reference meaning it's just the initial cut at this, kind of a point of departure, a discussion, an item to begin the discussion, and also your design reference missions, and this is basically how we see the whole thing working when it's implemented. This allows us to get what technically we call level 1 requirements, or top level requirements, which there aren't a whole bunch, but they're all big level requirements that you can then flow down to the Constellation program down at Johnson Space Center to do the actual detailed design. And the centers, which is where in NASA where all the technical expertise is, are the ones that work on the operations concepts. They're the ones who determine what technologies are needed in order to implement this particular strategy and this particular architecture, and flow the requirements down to the individual elements. The CED shall do this, the lunar lander shall do this. Next slide, please. Okay, so let's start by talking about the global exploration strategy. Where did that come from and how do we determine it? Again, as I said, this kind of gives us the big compelling reasons as to why we're doing this. It's why are we going back to the moon? Well, we define that by what we call themes. There are 6 overarching themes I'll discuss in just a moment as to why we, and that means all the stakeholders feel we should be doing this. And then what are we going to do when we get there? Well, we polled a tremendous amount of stakeholders on this one. We collected 800 initial ideas after there was, of course, some overlap, there were some duplications. Some of the ideas, of course, weren't as good as other ideas. We were able to distill that down to about 180 objectives of what we're going to do when we get there. Now, I should probably at this point, when we get to the next bullet, this is a global exploration strategy. The idea there is we at headquarters, or we as NASA, were not the only people who determined what these objectives are and these themes were. Last April, we convened a conference of the 14 international space agencies. We also got representations from academia. We got representatives from the commercial sector and from non-governmental organizations, all with the idea of coming together and what are these themes and what are these objectives. We also opened it up to the general public. If they could suggest themes or objectives through our website, they were also collected and considered by all of the stakeholders when we determined what these themes and objectives were. And so that way we can make sure that everybody is covered when we're trying to determine why we are doing this. As I said, the global, I talked about that in just a moment, who it is that was there. And I want to emphasize here that this is not just the moon. Yeah, the moon is kind of the shark closest to the boat right now, so that's the one that we're really concerned with. But this strategy should be extensible to Mars. This should be all of a piece about how we're going to extend human presence across the solar system. Next slide, please. So I said themes. Well, this is what was identified by all the stakeholders as the 6 primary themes, the whys we're going to be doing this, and how this, and then you'll see later how this informs our architecture and how then that flows down to the requirements on the individual elements. The themes that we identified were human civilization, that is the spreading of human civilization off of the Earth and across the solar system. And that was considered one of the major themes of what we're trying to do. Scientific knowledge, of course, is tremendously important. What can we learn about the universe, either by visiting these celestial bodies or the various capabilities that we will develop, how that can be used for scientific purposes. Exploration preparation. Again, we want to extend human presence across the solar system. We're going to be sending out outposts on distant bodies. And we need to learn how to do that. We've never done that before. The space station, of course, is only 220 miles. It's much further to get to the moon, and it's even further to get to, say, Mars after that. And speaking as someone from a flight test background, if you're going to be doing something risky for the first time, you want to do it as close to home as possible so you can get home quick if you have to. And if we're going to be testing out new concepts about how we're going to live on a non-Earth body, I would rather be 3 days from home than 6 to 12 months from home when we figure out how to do that. Global partnerships is something that's very important that we've learned from the International Space Station, and that is by working together on a large project such as a lunar strategy or a lunar system, that helps international cooperation and does everybody a lot of good. Economic expansion, I think, is something that many people here are interested in. That is the extension of the commercial sphere, the Earth's economic sphere, to include the space directly around Earth, to include the moon, and to include other bodies. That's something that we need to figure out how to encourage and make sure that happens also. And finally, public engagement. We need to be able to do this in such a way that the public understands what we're doing, understands the value of what we're doing, and try to damp out some of the public relations issues that we have. We need to be very transparent about what we're doing, why we're doing it, and try to keep that when we're designing our architecture, try to make sure that what we're doing is well understood. Next slide, please. So, okay, we've got this strategy now. We've got those 6 themes that I went over, and we've got the 180 objectives, and I'm not going to bore you by going over all of those. You can pretty much imagine what those are. So now that we have this, how are we using it? What was the value added to the NASA for that particular document? Well, what this does is it gives us a high-level story. It tells us a story about what we're doing that's extremely important, at least in my current day job, where we have to go and explain to our stakeholders on Congress or in the executive branch what is it that we're doing and why are we doing it and why should we be spending taxpayer dollars at a time where we're running budget deficits on this sort of issue. So we got a nice story to tell them there. It also can explain that to the general public. Again, it's coherent, it makes sense, this is what it buys you, and this is why you should support what we're doing. It also is a good starting point, a method of coordinating and collaborating with our international partners or any other organization out there, whether it's international, non-governmental, or commercial. That is, you could coordinate your efforts. You wouldn't necessarily have the same program, but if we all can get together and say, these are the objectives we're trying to do, well, I could take these 20 objectives and you could take those 10 on the lunar probe that you're going to send and kind of divvy up the work, and you make sure that no one's overlapping and that all of the bases are actually covered. You can also use it for collaboration. It will identify areas where 2 countries can come together on a particular program and work closely, such as in the International Space Station. And of course, you can use the information you get from this to flow down into your mission design, which I'm going to talk to in a minute in our lunar architecture efforts. Not just the time phasing, what are you going to build when, what's the highest priority, and also any impacts of the strategy back on your architecture. Next slide, please. So the thing that we're working on right now is what we call a framework for coordination. This is the international portion of this collaboration and coordination effort I was discussing. We are working with 14 other space agencies, all the major space agencies across the world, and started work last fall, late last summer and fall, and right now we're working towards a document that we call the Framework for Coordination, otherwise known as the framework document. It's not been released yet, it's going through its vetting right now. We're hoping to release that this particular year. It's an important step on how we are going to go ahead and coordinate and work with our international partners to make sure that we're all pulling in the same strategy and all working together on this and don't get at cross purposes. Next slide, please. This framework is not a prescriptive document. It just identifies a common set of these themes that we saw earlier and the values and what it is that we're all trying to accomplish out there that everybody can sign off on. It isn't a proposal for a single program like the space station where everything is supposed to fit together. Everybody's going to have their own international program with their own goals and their own priorities. However, this allows us, as I said, a way to coordinate and cooperate as opposed to make sure that all of our efforts are covering everything and we have less overlaps. It's voluntary and it's non-binding, and another piece of this is that it's going to have a forum, a cooperation mechanism as part of it where we can get our efforts, where we can meet together, make sure again that our efforts are non-overlapping and are covering the waterfront as we need to. And it's also a forum after we get this stood up to promote space exploration to the governments and the public across the world. Next slide, please. some of the things that we've already identified that we need to work together with some of our international partners on. And many of these will also would also have to be coordinated with the private sector too, as they become larger players in the space business, is the identification of standards for interoperability. It would be good, say, if we all used the same power, you know, the 120 versus 240 volt issues we have now. It would be awfully embarrassing if we were building an outpost on the moon and we have to put in a bunch of power converters like you do when you travel to Europe these days. It also would be good if various modules of all the spacecraft could dock together so that they can render aid or be used more flexibly. We want to identify methods for sharing scientific data and analysis. No one country can afford to send all of the probes to the moon that it wants to get all the data that it may need. This way, you can coordinate about who's getting what data and then sharing that data back and forth. It's much more efficient. We may be able to identify common services. For example, if we're going to coordinate on an outpost, we only need one power system. Just make sure that that power system is large enough. So we need to coordinate and say who's going to be building these things and under what standards. We need to allow for the provision of payload opportunities and the horse trading that kind of goes on there with, say, trading of crew members versus contributions in other areas, or payload space and the time for the crew people up to service those payloads. Ways to include broader future participation. We're thinking that going to Mars would involve a great degree of international coordination of resources and of efforts, and we need to have a forum or some way of working forward to that. And finally, for all the lawyers in the room, I think this last bullet is really fascinating, and that is what sort of legal regimes are going to be necessary when we start actually having outposts on the moon. There's going to be some very interesting questions there that need to be addressed in this forum. Next slide, please. Okay, given all that, what are our plans for this year? What are we trying to do right now with this? We're trying to extend the discussion onto Mars. We pretty much got the moon thing, the moon portion of this completed. We're going to try to extend it to Mars so we can start seeing how that feeds back into our current strategy and thus our architectures. We're trying to complete this framework document I talked about. We're going to work on this coordination mechanism, as I said, and also using the reference architecture that we've already come up with here that I'll discuss in a moment, use that as a tool for coordination. Now that we actually have an architecture, we can having people step up to the plate and say, yeah, I can build this element, or I can build this power system, or I can build this transportation system. Kind of shifting gears for a moment, one of the things we've also defined that we need to do this year is explore areas of commercial participation. How is it that we're going to get commercial folk also playing on a level playing field here? And we want to continue refining our architectures, get more cost data, get more technical details hashed out as we go forward. Next slide, please. Okay, I'm going to move now to our architecture. That's kind of the big picture. That is how we've determined what the whys and the what's. Now I'm going to talk a bit about how we determine the how. Primarily last summer, we kicked off what we called a Lunar Architecture Team. We didn't call it the Lunar Architecture Team #1 back then because we thought there would only be one. Turns out we had a second one, so now we, in typical government fashion, called them the LAT 1 and LAT 2. The output of the initial architecture team was, for those of you who were down in Houston last December 2006, was revealed there. It was basically just our point of departure architecture. That is, we were using various ESAS elements. We determined that we wanted to go down to the Shackleton crater, etc. And it came up with a bunch of notional designs of vehicles of what we think all the various elements would look like. This was not by any means a baseline. It was mainly just so that we all, the internationals, commercials, everybody had kind of a common discussion point, a common jumping off point for when we determine where we're going to go with the architecture. Since in January, we kicked off LAT 2, and the idea there is where we are incorporating inputs now from the internationals. We're trying to pay more attention to areas such as cost, refine some of the scientific data that we're going to try to pull out of this, and this refined architecture will be reported out at the Space 2007 conference coming up in September. So I would ask all of you, that might be a very interesting thing to see, so I suggest that all of you also attend that event. Next slide, please. Now the question is, what are the big questions that we are going to try to address by the architecture? Now that we have our strategy, there's a bunch of questions kind of flow naturally out of there. We have to answer through the analysis and when we're putting our big system together. And that is, what are our priorities and what is the phasing driven by those priorities when we actually go back to the moon? And how do these priorities drive some of the more important decisions you have to make, like an outpost versus sorties? Are we going to all the time going to be going down to one place on the moon? Are we going to do like Apollo, where we do sorties to various places for a couple weeks at a time? In their case, 3 days, we'd be staying longer. Where is it that we want to land? You know, if we are only going to put up one outpost, where is it going to be? And finally, how flexible can we make this architecture? I mean, we're not going back to the moon until about the 2019-2020 timeframe. Things are going to be different then. There's going to be different opportunities and different priorities. How much flexibility can we bake into this thing to take advantage of those at that particular period of time? What attributes, given the more internal NASA needs, such as preparations for Mars or opportunities to partner with our international or commercial partners, how do we need to design this architecture to take advantage of those? And how can we show the public that we're making sustained and visual and visible progress while we're doing this? And now, if we have an architecture, what parts do we want to develop? What parts do we want to leave to other people, whether international or commercial? And finally, given that we're in limited resources, how do we allow for like the optimum capability? You know, we don't have all the money that we would like, so we have to kind of prioritize what pieces are we going to buy, and what pieces we're going to ask other people to buy that are enabled by our transportation architecture, the limited amount of down and up mass we have at the moon, and the limited amount of power that we're going to have when we get there. Next slide, please. Okay, so the first, kind of addressing the points that I raised there one at a time. First key decision you have, sortie versus outpost. We determined, if you were in Houston last December, we determined an outpost, and primarily for the three themes that you see listed there. Exploration, preparation, it allows us to prepare for Mars. When we go to Mars, we're going there to stay due to the orbital mechanics and how difficult it is to get there. We'll be staying for a while. So let's practice that on the moon before we go back to Mars. Human civilization, this allows us to start spreading human civilization across the solar system by spreading it to the moon. And economic expansion, it's much easier to do commercial exploitation of an area if you're there for an extended period of time than when you're just jumping from place to place for a couple weeks. It also enables global partnerships a little bit better because people can contribute more infrastructure to one fixed area. It allows us to develop and maintain in situ resource utilization, or ISRU. If we're there long enough and understand the resources that are there, we may actually be able to draw water or other resources from the moon. And we'd also like to do that for Mars, and this will get us practice on the operations of doing that. It also allows us, we feel, the quickest path towards other destinations, whether it's the Mars or other planets or other destinations in the solar system, again, by giving us the practice of living for an extended period of time out there. And we could also satisfy many size objectives, especially if you could use this as a jumping off point for sorties. So if you look at an outpost and this architecture that we put together, which involves an outpost and the various ESAS elements, as I said earlier, this supports the establishment of a Mars analog and allows us to start a sustained presence on the moon. We can develop long-duration systems. Like some of the very challenging things we have is how do you develop a life support system that can hold together for as long as it needs to if you're going to be there for an extended period of time. You're going to be there years. It can't be something that breaks all the time. We need to understand the engineering behind that. It allows us to understand the human element better. Believe me, the sense of isolation you have out there is much greater than the sense of isolation you have if you're just in a room down at JSC for an extended period of time, and some of the analogs they have for extended, for humans being in a confined space for a long period of time. We need to understand the human element both physiologically and psychologically better, and so an outpost will allow us to explore those ideas better. We can develop operations about how you would operate on a planetary surface for an extended period of time, and gives us the opportunity to start investigating how we would learn live off the land. We don't want to have to haul all of our resources with us. Gives us the earliest opportunities for commerce and international partners, as I said earlier. The infrastructure, we can allow other countries, other entities to supply infrastructure, whether it's communications, power, perhaps building materials and building expertise. We're going to have to establish, of course, standards and commonality, simply because all these pieces have to fit together when you get them up there. ISRU is a very good potential for commercial and international participation, especially if someone figures out how to take resources from the moon. We presumably will not need all those resources, and someone else might be able to purchase those. And finally, the hub architecture that we put together ties it all together literally in that you have a hub with items which kind of snap or plug into it, and figuratively, and that is it's kind of the center of all of the efforts that you'll have up on the moon. Next slide, please. I think I'm out of phase there. Back one, please. Excuse me a moment. No, other side, okay. Bit of those technical issues I was talking about earlier, my apologies. Okay, next slide, please. Okay, the other things about this particular architecture is it allows us to show measurable progress to the general public. As items are flown up there and are integrated into the architecture, they could see that, just like the space station, they could see the thing growing, and they could see the progress that's being made. It's very visible. It allows people to say, yes, there is, your resources are being used wisely, and we are making particular progress. And allows us to have a focus for our public engagement efforts. If we look at the human and robotic missions that we have up there at an outpost where people are living all of the time, that gives us an awful lot of opportunities for good public engagement, and also allows us to even allocate payload towards it. Next slide, please. Okay, so our strategies show that we can allow this, by working on our lander, a particular element, which is the crucial part, of course, is a lander that takes the pieces, say, down to the surface. We show that we can, if we take these themes in mind, we can modify our lander to be able to emphasize these themes more. For example, as opposed to like the LEM where you had like a large landing part and a large ascent part, you would make the ascent part, the part that goes from the lunar surface back up to the equivalent of the command module or the CED in this particular case, as small as possible. You're only going to be in it in a little while. That allows you to leave more mass down on the lunar surface that could be used to build up your outpost. Or you could just not put the ascent module on at all and put a habitation element or some other large piece of cargo on it. This we believe that will give us the least expensive and the most and the quickest outpost buildup with no more than about 2 of our heavy lift vehicle, the Ares 5 flights a year. And we think this is a real enabler for the missions that we're trying to undergo at the moon. Next slide, please. Okay, now, given our architecture, how are we going to implement this thing? Well, and this kind of gets back to commercial and international opportunities that are out there. What we're going to do is we're going to build a transportation infrastructure. We're going to build all of the critical path elements to allow us to get to the moon and set up shop. That is kind of our agreement with Congress and our agreement with the executive branch. We're going to do the critical path elements. Now, it's going to be in an open architecture so that anybody who comes in and says we want to do X as an addition or as a supplement to your architecture, we're going to make sure that the standards are clear and that the architecture is open so anybody can just plug and play as easily as possible. And we want to perform some early demonstrations to kind of show people how they could fit into this particular architecture. However, I would like to say the parallel development of some of our capabilities is welcomed and in some cases encouraged. And if I could drop down here for a moment, I think an example of that is COTS. We are right now, as part of our architecture, working on low Earth orbit transportation. We're also encouraging commercial development of low Earth orbit transportation, and when that is developed, depending on, of course, the price and the operational flexibility of the private industry when it actually is there, we will take advantage of that. If it's less expensive, for example, to lift crew from a commercial provider than it is to use our organic capability, it's going to be a very hard case to make to not take advantage of that. That will allow us to take resources and direct them where we want to go, which is the exploration of the Moon and Mars, and not on areas that other people could do perhaps more efficiently. Next slide, please. Now, as I said, there's plenty of opportunities for cooperation. Well, there sure are. This is a list that the architecture team identified of the various tasks, the various capabilities that we're going to need. The ones that we're developing and we don't need any capabilities on if we finish, when everything is completed, is just the stuff there in blue. So you see a vast majority of the capabilities that we feel we'll need on the moon are not fully addressed. In many cases, we are addressing them, just not to the degree that we'd like. So there are plenty of places for other players, whether it's international or commercial, to play as part of this architecture. Next slide, please. Okay, now, after all this, after we have our outpost, one of the advantages of this outpost architecture is after it's built up in the 2020 timeframe, it's very flexible. We can proceed in various different directions or depending on what's important at that particular time. Again, this is going to be a couple decades from now. We're going to have these capabilities that are listed there in the slide. Basically, we'll now have a mature transportation system. We'll know more about what it's like to live on an external planet for an extended period of time. We'll have our EVA systems down. We'll understand something about ISRU. We're going to know how to work with our international and commercial partners. And then we can decide at that point, is it time to pull up stakes and go to Mars? Would it make more sense just to expand our outpost? Are there some really interesting things happening there and we need to put our resources there? Do we want to start doing things like spinning the outpost off to an international consortium or a commercial partner, make it a national lab, and then go on to Mars? Or is it better to have NASA to continue to administer it? That kind of gets into the legal regime that I mentioned earlier. And finally, maybe there's other lunar sites that would be interesting too, to either do sorties to or maybe build another outpost. We don't need to make that decision for a long time. And again, this is some of the flexibility I was talking about earlier, that we could take this particular architecture in any of those directions. Next slide, please. Okay, so finally, given all that, what are we trying to do here through the remainder of the summer when we're working on our architecture team? Finally, we want to just update our objectives, continue to coordinate with the international partners that you see here. We want to continue working on the architecture concepts. There's still always refinement that needs to be done. We want to start working on the Mars reference mission and see how that feeds back into our lunar architecture. The Constellation program right now is working on updating and baselining their lower level requirements. We're baselining our higher level requirements and making sure we have a good, complete, consistent requirement set to build to. And we're going to continue to engage academia. We want to engage commercial players. We want to engage international folk, all on defining this sustainable program. So that's what we're going to be concentrating here in the near term. Next slide, please. Okay, I've talked quite a bit about the top level and the architecture side, and you'll notice there was an awful lot of discussion of international players. And I thought, given this conference, I want to speak a little bit about our commercialization efforts that are also happening in ESMD at this particular time. It is important. We are serious. We want to engage the commercial focus, something we really haven't done in the past. And right now, we're working on how we're going to do this. We formed internal to ESMD what we call the Partnership Integration Committee that coordinates how we're going to work with our commercial and international partners. The gentleman who is working this for us is named Ken Dpty. He's here today. He's been working Centennial Challenges in the past, and is definitely the right man for this job. He understands the commercial needs, and he understands how we can think out of the box to incorporate it into our architecture. We're trying to develop right now a commercial strategy, a methodology, a process for integrating or at least not discouraging commercial participation into the global exploration strategy and in the lunar architecture. And that's starting to come online. And of course, if anybody has any good ideas on what we're doing wrong or what we're doing right, please, we have the email address right there. Please send it to us, and we're very interested in getting your input. The goals of our commercialization strategy is primarily to encourage the private sector to demonstrate and provide commercial capabilities to us. And that's kind of an important word there, demonstrate. Remember I said that we at NASA are going to build, we feel responsible that we have to make sure that that critical path is built. That was the deal that we made. So we cannot at some point say that, well, we're not going to build this link in the architecture, or in this, say in the transportation architecture, because we feel commercial capabilities can do that. If commercial capabilities are demonstrated and a market develops, then we can do that because it's been demonstrated, it's a real capability. But until that capability is demonstrated, we can't just kind of bet that that capability will be developed. Personally, I think it will in the case of low Earth orbit transportation, but until it's actually demonstrated, we can't take advantage of that. We also want to conduct and construct and then conduct collaborations in such a way that the private sector can maintain their intellectual property rights. Of course, if you have to give your intellectual property rights to the government, that does not allow you to actually be successful in a particular market. So I know in many cases we've been working very carefully as to how we structure this to not to allow people to keep their IP rights and be able to make a viable business. If there is commercial capabilities out there, we need to take advantage of it. We need to do that as more than just lip service. And that's something, some hard decisions will be made down the path. But right now, with current leadership and our current policy, we will do that. There's no doubt on that. The other thing that we're trying to do is to encourage multiple smaller companies to try to get a more broad industrial base. You know, our current contractors are great Americans, they're very good, but it'd be nice to have more, nice to have a broader playing field to work with there, to develop more operational capabilities and also kind of spread the experience out a bit. Next slide, please. Now, one of the things that Mr. Dpty has worked on, this is an eye chart. I don't expect you to read it, but this kind of tells you our approach to commercialization within ESMD, and that is this kind of a model, state-based model of what it takes to kind of get a business going, to develop a capability in an area where there's no capability. The blue boxes are the actors and the green ovals are actions. And in order for a company to get a good idea and grow it and get financed, we kind of feel it has to kind of navigate this particular maze. But if you look at the particular area of space, we've identified a whole bunch of roadblocks that occur in some of these actions. And there's probably more than that, but these are the main ones that we concern ourselves with that we feel that we need to address. Then finally, so if we're going to address these, we're going to look at a subset, primarily what we feel the larger ones are, and these are the 4 that we're addressing right now with our commercial efforts within ESMD. Specifically, roadblocks such as attracting funding, whether it's from angel or VC, but we send positive signals to the investment community. Next slide, please. I think I got ahead of you there. Next slide, please. Thank you. We're trying to send positive signals to the investment community so that we can attract funding, not only by doing something like COTS, where we're assisting with the technical side, but also by saying that we will take advantage of commercial services if and when they show up. The actual production of goods and services, we do that by funding demonstrations, either through Centennial Challenges or through COTS, and also by becoming a customer when it's available. Next slide, please. Okay, I think we're still in sync here. And again, our commercialization efforts are primarily COTS, which is a capability demonstration. We pay for performance there to ensure that we actually have a real capability as opposed to just paying the usual contracting rules. Centennial Challenges, technically that's now been moved to the Innovative Partnerships programs of NASA, but we're still connected because Ken Dpty is running both of those, but they tie what they're trying to demonstrate back to our technical requirements. And finally, we're working with the Space Operations Mission Directorate on future transportation procurement efforts, specifically COTS Phase 2, which is when we're going to do space station resupply using the COTS developed demonstrators that we've been working on. And finally, we are working on things such as BAAs and other future opportunities for people to play in the future. Next slide, please. Okay, thank you for your patience on this. I'd like just to wrap up here saying that our global exploration strategy, the big picture, is still a work in progress, but I think it's mainly there. It's informing our strategic and our architecture decisions when we're looking at what we're doing. In concert with our programs, we're trying to refine our lunar architecture. We're trying to pull in the internationals. We're trying to make more efforts to pull in the commercials to make sure that people are actually able to play. Okay, great, we're operating down here now. And finally, we're trying to encourage the development of capabilities, primarily by removing roadblocks we see that are in folks' way. And also trying to investigate future partnerships and participation in the exploration vision. And if we do all this correctly, we can all participate in the future spreading of human civilization across the solar system, which I think is going to be very interesting and motivating time to be in the business and in the space community in general. So next slide, please. told I have a few moments. Yeah, that is pretty motivating. I've been told I have a few moments for questions, so if anybody wants to stand up and come to the microphones, I'd be happy to take questions you have on ESMD's strategy or our architecture. I think you were first, sir.
Thank you. I actually have two questions. The first one's short.
Okay.
Do you have, or will we have access to the PowerPoint presentations after the conference? Because many of these have great information I'd like to look at.
I believe so, but you'll have to ask the organizers on that one.
Okay, so you can't. I would like to put in a question.
Okay, I'll leave a copy of these slides here. There's no reason I can leave that.
And the second question is about strategic plan. It seems to me that public support is the biggest single concern. Without public support, we don't go back to the moon, we don't colonize Mars, you don't certainly terraform. With the threat of global warming hanging over the public's opinion, how can you structure space exploration so it becomes a part of the public's perception of the solution as opposed to the problem?
So you're asking specifically in the case of global warming, how can this architecture apply towards that?
Global warming is the current buzzword, but
Yeah.
I think we need to start looking at how do you guarantee support for space in the face of all these calamities that could come down.
I think that is an excellent question, and I think there's kind of two ways that I would answer that one. Number one is kind of through the flexibility that we're trying to build into the architecture. As you put it, buzzwords that are going to be around when we're flying this thing. We don't know what they are now, but we can't predict that. But if we build this thing sensibly and flexibly, we could deviate or add capabilities at the time that allow us to address whatever is important in the public's mind at that particular time, if we design it flexibly enough now. Furthermore, we do, through the exploration strategy process, do try to pull the public in to try to understand what the current issues are and incorporate into what we're doing. Now, for something in this particular case, global warming, it might be a little more difficult because we're focused kind of on going to the moon, and I'm not a scientist or trained as a scientist. I don't know how that may or may not help you in trying to understand Earth's climate. It might, although I can't really see how. Although, if I'm just kind of thinking on my feet here, which is always dangerous, some of the transportation capabilities we have, such as the Ares 1 or the Ares 5, could perhaps be used to loft larger or more capable satellites to be used to track global climate change. But the idea is that we have a system that's flexible enough to be able to go in different directions, as you will. I think that's probably the primary way. We figure out what it is through the exploration strategy, what it is that they want, and then have a architecture that can attack that. Does that answer your question?
I was going to say, if I could follow up, it just seems to me that global warming is indeed the buzzword that is now and possibly in the near future going to be the biggest thing. And I don't see this community responding as if that is going to be a problem that we're going to need to concern ourselves about. And I think if you lose the public support because global warming grabs it, and it's already grabbed it a lot more than we have, we're going to be, without a path.
We'll be at a disadvantage, I agree. I think when we have the capabilities developed, when we have, as I said, we might be able to, for example, use our transportation capabilities to launch satellites to address, in this case, climate change. Once we have the capabilities developed, we may be able to use them to address either global warming or any other concern of the public at that time. Unfortunately, we're still in the point where we're developing those capabilities, whether it's for the standard architecture or anything else. Until we get those developed, you're right. We're kind of saying, we're trying to help. That's, yeah, fair enough. Good question. Thank you. Next slide, sir.
If we want to go to the moon in the long term, be there for a long range, establish civilization, and provide economic opportunity. My call,
Okay.
If we intend to be on the moon for the long term, and to establish civilization and to provide economic opportunities as two of your main themes, how is it and why is it that the current iteration of the lunar lander design won't allow it to use lunar-derived propellants? Please correct me if my understanding is mistaken, and please explain
I believe you're talking whether we're using a LOX methane engine for the ascent stage or not. I would say that sort of issue, correct?
Yes.
Right. When you're making the particular that's a technical trade. That's primarily down at what we call the lower level of the 3 levels I described there. You know, what is the best technical application to meet the priorities that we've passed down in the program? And remember, there are multiple priorities when you're doing a trade like that. There are multiple priorities. You know, just because you do not take the architecture, make a technical decision in a particular direction, does not mean that that priority is not important. It's just that there was some other thing that was more important. And also, I would say that an awful lot of these particular trades are not closed yet. They are still working on the lunar lander design. You may or may not see that trade when we get our priorities down and we look at it again more closely over the next few years. You may or may not see that decision going another way. I can't really say one way or the other. That would be speculation on my part. So, over here, sir.
My name is T.D. Lin. I'm a research professor at National Cheng Kung University in Taiwan. Currently, there are 6 universities gathered together, submit a proposal to National Science Council of Taiwan to get funding for research on developing how to make cement and concrete on the moon.
Yeah.
Also, on the Mars. There will be 12 professors involved. My question to you is, when we get the result, and I saw your presentation, you're going to build something, infrastructure on the moon. I believe for Taiwan to make this kind of construction is impossible. NASA may be interested in it. How would you want us to communicate with you when we get the test result?
I think the best thing for your answer there, just for the short answer, is talk to me right after this. All right, let me talk to you and I'll put you in touch with the right people. But a bigger picture, taking a step back, is that's exactly the sort of thing that we're wanting to hear. You know, there's a lot of capabilities that we don't have the time or resources to develop, but we want to coordinate with folks like yourself so that if you come up with a method of making concrete that would work in lunar or Martian conditions, that, okay, we'll buy a whole bunch of it, or you can contribute a whole bunch of it, and we'll respond in kind, and actually we can collaborate on this. I think that's an excellent example. Thank you. And just talk to me after this, and we'll get in touch.
Thank you.
Yes, sir.
Good morning. I was happy to see your solicitation of outside ideas and an email address to do that. I think, however, that there is a pretty widespread impression that NASA's solicitation of outside ideas, outside of a fairly narrow circle, is mostly a pro forma exercise. I think it would go a long way toward alleviating that impression if NASA could point to specific examples where ideas outside that narrow industrial range had in fact been adopted. And I wonder if you could do that this morning or point to anything specific.
I would like to think that some of the innovations that we're taking, such as centennial challenges, or to a certain extent COTS, are examples of kind of out-of-the-box thinking, where we have done something differently. We did not go through the standard contracting rules, standard cost-plus contracts. An awful lot of those efforts were taken after discussing with people from outside NASA about what do we need to do to energize what it is that you are doing to help you. And we're trying to think up more. So that's what I would point to, those 2 cases of examples where we're trying to do business differently. And I hope that we can get some more, because actually those are really fun. Next, please.
We bet. I first want to thank you for doing a fine job of outlining the broad organization of the exploration effort. I think that's very helpful to us. We've had a lot of experience in trying to work with the agencies of other countries, going back to Apollo-Soyuz. How confident are you that we're taking advantage of lessons learned? I didn't hear anything about that.
Lessons learned from international...
Working with other space agencies in other countries in Apollo-Soyuz, shuttle, STS.
I could be flip and say that most of the people who are doing the international stuff now have been the ones who've been working space station in the past, and they kind of bring their experiences and their scar tissue over with them. But yeah, when we're working on that, we are keeping in mind what we have learned and what has and has not worked in the past. One could say this particular structure, if you'll notice the forums that we're discussing aren't like binding. We're not forcing everybody into a space station-like situation where, we're all on one big program. One could make the argument that we learn something, the way that we're structuring this is based on lessons learned, the advantages and disadvantages of that sort of approach. And so there are some ways that we're doing things a little different based on that.
Was there a specific module that you could have called lessons learned, where somebody stopped to examine these previous phases?
I'll be honest with you, sir, I do not know when they were developing the global exploration strategy at some point where they sat down and looked back at the space station model and, as you said, Apollo-Soyuz in the history of international collaboration going back. I would imagine that they would, because I know the people who did this and they're very thorough, but I do not know for sure that that happened. Okay, I think I have one more question. Okay, yes, sir.
Last year, an assessment was published as to why the DoD Geospatial Agency was having such success in purchasing imaging from the commercial sector. And the single biggest lesson learned from that was that they agreed to upfront stop competing with the commercial sector so that the funds and everything would flow in. We haven't taken that attitude in NASA yet. And I'll give you a particular example and ask you to comment on it. The simplest one. Mike has said several times that one of the things still on his radar for putting money into up front is a government-owned cislunar communication system, telecommunication system. And yet, telecommunications is the one mature space industry on the planet, something where if you just tell people what you need, you can purchase the service without developing a government-owned thing. That's just one example, but could you comment on that? Because I haven't detected one iota of realization at the headquarters that the need to stop competing in those certain sectors X, Y, and Z where the commercial sector could step up, to stop competing has to occur first. It's not, we're going to compete the hell out of you, expect you to raise money, and once they're fully developed, then we'll purchase it, which is the current broken policy.
Actually, I think I can address that. And you're right, it is an issue, because remember, Mike has directed that the critical path elements, which includes communication when you're on the moon, need to be organically developed, because he does not want to have to depend on a non-NASA organization to do that. But if you remember the slide I had with all the commercial opportunities and the ones that we are at NASA are working on in blue, you'll notice that the communications is just basic communications. Just the voice and probably a small amount of video, not 100% comm coverage, for example. It's just going to be enough to get us by. However, we all know, the need for bandwidth just increases geometrically once you figure out what to do there. So we will have just a bare bones communications capability in this particular instance. What that is, I can't tell you right now, but that's the approach. The necessary enhancements that we know we're going to need, a lot of bandwidth for HDTV, a lot of bandwidth for the data the telemetry we're getting from scientific experiments. We intend to get those commercially. So there will be a great need for capability there, but we'll still be able to establish the outpost. Because we can't establish the outpost, there's no market in the first place. So thank you for your question. Anything else?
I think that's it.
Okay, thank you very much. And thanks for your patience on the slides there. That was fun.